Okay, we're going to work some examples now from section 7.3 on the ellipse. We're given an equation. This one happens to be in the standard form for an equation of an ellipse, centered at the origin, and we're defined A and B, the major axis, and the vertices. Okay, so recall that the larger number is going to be under the variable for the major axis. So since 16 is bigger than 7, then we know that the major axis is the x-axis, and that tells us that the vertices are at plus or minus a 0. Well, what's a equal to? A is equal to the square root of 16, or 4. Remember, this is a squared. And b is equal to the square root of 7. So the vertices are going to be at 4, 0, and negative 4, 0. We can write our a and b over here. A is 4, b is the square root of 7. Okay? Because it's a squared and that's b squared. All right. Example 2. Again, we're still in standard form. We know that the larger number is a squared, sorry. So a will be the square root of 9, or 3. And b will be the square root of 1, or 1. The major axis is the variable with the larger number under it, so it's the y-axis. And the vertices on the y-axis then are going to be 0 and plus or minus a. 0, 3, and 0, negative 3. Okay, example 3. This is not in standard form. How do we know? It has to equal 1, doesn't it? Can I rewrite this where it equals 1? How would you do that? How could I use some algebra and make it equal 1? Right, I would divide every term by 36. And what happens? We get x squared over 4. 9 over 36 is 1/4. Plus y squared over 9, because 4 over 36 is 1/9, equals 1. So what's the major axis? Yes, the y-axis. So b squared is 9, so a squared is 9, so a is 3, and b squared is 4, so b is 2, and the vertices on the y-axis are 0, 3, and 0, negative 3. All right, again, we are not in standard form, so we'll have to divide each one of these by 40, each term, and we get x squared over 8 plus y squared over 5 equals 1. So a squared is 8. So a is the square root of 8, which is what? 2 square roots of 3, right? And b is the square root of 5. So a is 2 square roots of 3, and b is the square root of 5. Major axis, well, the larger number when we were finished was under x squared, so it's the x-axis, and that means our points are, how did I put 2 square root of 3? Of course it's not, that's 12. Were you thinking that? Thinking, where did she get the 3? Right, it's 4 times 2, so take the square root of 4, right? Let's fix that. That's the square root of 8, 2 square roots of 2. Okay, so our vertices are at 2 square root of 2, 0, and negative 2 square root of 2, 0. Last one, again, not in standard form, but we can get it that way. We divide everything, every term, by 24. So we get x squared over 4 plus y squared over 12 equals 1. So b squared is 12, so b is the square root of 12, and that's where I get my 2 square roots of 3, right? 4 times 3, take the square root of 4. And, did I say b? I'm going to make a mistake no matter what I try to do. There we go. B is the square root of 4, or 2, right? So we have 2 square roots of 3 and 2. All right, so our major axis is the y-axis. That tells us that our vertices are at 0a and 0, negative a, right? So we have to know the axis so we get these vertices on the correct axis.